In the previous chapter, we talked about vectorizing, about feature vector. We talked about document or matrix, and we also talked about the various types of vectorization that we have. So we talked about the count vectorization, the n-gram vectorization, the turn frequency, inverse document frequency, or popularly known as TF-IDF vectorization. So in this chapter, we're going to try to understand what count vectorization is, and we're going to mainly focus on count vectorization. So count vectorization is a way of creating a document or matrix where each cell represents the number of times the word appears in the particular document. So let's take a look at an example and try to understand what count vectorization is. So let's suppose we are dealing with these two text messages, and we have these two text messages inside our file, and we are trying to create a document or matrix using count vectorization on this particular file. So here we have two documents, and inside the document or matrix, the number of rows would represent the number of documents or the number of text messages that we have inside our file. So here we have just two text messages or two documents inside our file. So we have just two rows in the document or matrix, and the number of columns would represent the number of unique words inside our file. So we have 7 unique words inside our file, and those represent the columns in our document or matrix. And if we use count vectorization for creating the document or matrix for this file, we'd have this kind of a matrix. So in the first document, the first row represents the first document or the first text message, and in the first text message we have I appearing 2 times, love 1 time, NLP 2 times, very doesn't appear, much doesn't appear, am appears 1 time, learning appears 1 time. And in the second text message we have I appearing once, love 1 time, NLP 1, very 1, much 1, and am and learning do not appear in the second document or in the second text message. So this is how our document or matrix would look if you're trying to create a document or matrix for this file or for this set of documents using count vectorization. So let's try to implement the count vectorization for our data set. And here what I've done is I've simply read in the file. So just for a reminder, we are working with this SMS spam collection file, and this file contains a set of text messages which are classified as ham or spam, and we are trying to create a machine learning model out of that which can predict whether a particular message is a spam or ham. And inside this method, what we are doing is we're just cleaning up the data. So in our previous few chapters, we have been doing this using various methods. We have been removing punctuations, tokenizing our data, removing stop words, and stemming the data in separate places. But here what I've done is I've just put everything together inside this method clean text, and this basically takes in a string, a text message, and then first it removes punctuations from the text message, from the text or from the string, and then it tries to tokenize the text or tokenize the string into a list of words, and then we remove stop words from the list of words, the list of tokenized string, and then we try to stem each word inside the list, inside the tokenized list of words, and then we return that stemmed words or a stemmed list of words, right? So that is what this definition, that is what this function does. And now we are going to apply count vectorization on our data set. So all I'm going to do is import count vectorization. So I'm going to say from sklearn dot feature extraction dot text import count vectorizer, and I'm gonna say count underscore vect. Alright, I'm gonna say count underscore vect equals count vectorizer, and we've been calling a lambda function to apply the cleaning on our data set in the previous few lessons, but we're not going to do that. Instead, we are going to call the analyzer inside count vectorizer, so that would clean up the data and form the documentor matrix at the same time. So I'm going to say analyzer, and I'm going to pass in the name of the method that cleans up the data. So I'm going to call clean text, and I'm going to hold the documentor matrix inside x underscore counts, and I'm going to say count vect dot fit transform. So we're gonna understand what fit transform is at a later point in time in this course. And we're working with our data set. So this is our data set, and it has two columns inside it, label and text, and we're working with the text column. So let's say data set text, right? And I print the number of rows and columns inside our documentor matrix. I'd say print x underscore counts dot shape, and I'm gonna run this. It's gonna take some time. So we have 5572 rows. So those are the number of documents, or those are the number of texts that we have, text messages that we have inside our file, and we have 8340 columns. So those are the number of distinct or unique words inside our file, right? So next I would say print count vect dot get feature names, and let's run this. So these are the columns that we have inside our documentor matrix, and we can see we have these words inside our documentor matrix as the columns. Right, so now we'll be trying to put our documentor matrix into a data set, into a data frame. So I'm going to say x counts df equals pd. So that's for pandas. That's a pandas library that we have imported here as pd. So I'm going to use that to create a data frame dot data frame and I'm going to pass in x counts. I'm going to say to array. So x counts is stored as a sparse matrix inside Python. Python stores x counts, or Python stores the documentor matrix as a sparse matrix. So sparse matrix is basically a matrix which has a lot of zeros inside it, and a documentor matrix is typically a sparse matrix where there are a lot of zeros inside the matrix. So while storing, Python does not store the whole array or the whole matrix as it is, because that will be a lot of space in the memory that would be needed to store that data. So what Python does is it just stores the location of the non-zero elements, and stores the non-zero elements and the locations inside the memory. So that's a lot less data that needs to be stored inside the memory. So that is how Python stores the document or matrix. And if we want to expand it, we have to call this toArray method on the document or matrix. So that's exactly what I'm trying to do here, and I'm trying to create a data frame out of it. So let's run this, and the document or matrix also stores the column names as some numbers instead of the actual text or actual words inside the document or inside the file. So we're gonna provide the names for the feature names as the columns inside our data frame. So I'm gonna say x counts dot column equals so that's gonna be count vect dot get feature names. So the feature names are gonna be the column names inside our x counts df data frame. And let's run this, and let's try to print the first 10 records inside our data frame. Let's run this. Okay. So we can see this is how our data frame looks, and these are the unique words that we have inside our file or inside our file, inside this SMS spam collection file. And these represent, the rows represent the text messages, the actual text messages inside our file, and these zeros or these numbers represent, actually these are all zeros, so that is what I was talking about. This is a sparse matrix, right? And these numbers represent the number of times this particular word appears inside this text message, and that is how we use that is how we can use count vectorization for creating the term matrix out of the data set that we have. So that is all for this chapter, and in the next chapter we're going to talk about the n-gram vectorization way of vectorizing data. And I hope you guys enjoyed this video, and if you did enjoy, please give it a thumbs up and stay tuned for the next one. Bye.